Hi ladies, it's Mr. O'Sullivan. Before I begin today's lesson, as you know, I'll be working remote for the time being. I'll be back in the classroom on November 16th. Students who come in person for 9th grade, I'll be Zooming with you during your class period where we'll go over the lesson. I'm not sure who will be covering my class, but someone will be covering my class and you will still be learning math, but you'll be learning with me through Zoom. Just want to get you prepared. So the learning target for today is I can determine the domain and range of a graph and a function, but before we even go into domain and range and actually determining it, I want you to write down under domain x and under range y, because we need to remember that the domain are our x values and range are our y values. The domain and range of a graph, it's not written as a list, it is written in interval notation, so we use parenthesis, bracket, parenthesis, parenthesis, bracket, parenthesis, or bracket, bracket. You can also write it as an equality notation, like say x is greater than 5, and you always need to start small and go large. So if it's not associated with a word problem, a graph that is drawn to the edge of a graph paper is understood to go on forever and ever and ever. Just draw your arrows on. All intervals except the range are asking for your x values or domain values. So, for each of the following functions I'm giving you, we're going to be answering a series of questions. The first thing we're always going to be asked is it a function? Well, since we're being given graphs, we know that if we want to figure out if it's a function, it must pass the vertical line test. So let's write that in. Function must pass the vertical line test. So, for the first image, we're going to draw on some vertical lines and see if it passes the vertical line test. It works so far. It works again, works again, works again, and works again. Yes, this is a function. It passes the vertical line test. You can abbreviate via vertical line test to VLT. Domain. I'm going to erase my lines that I drew in. We know domain is our x values. I'm going to be doing this part in blue. So here's what I want to ask you. How far to the left does your graph start at x? Well, if I look up, it starts here at 0. We only care about our x values. I'm now going to draw on my line, and if I look, it goes on forever and ever and ever and ever, and it has my arrowhead. So if I want to write it in inequality notation, I can say that x has to be greater than or equal to 0, which is the exact same thing as saying 0 to infinity. Remember, I always put a parenthesis around my infinity, and since it's a shaded or a closed circle, I'll put a bracket around my 0. Now let's do our range. I'm going to erase my blue now. Our range is our y values. I'll be doing this in blue this time. Red, sorry. Range is our y values. So I'm asking you how low and how high. So if I look, I start at 2. It's a closed circle. And I just keep on going up and up and up and up. I know that I'm going to hit every single number that's larger than 2 eventually. So I can say my range is y is greater than or equal to 2. And now if I want to do this in interval notation, I do 2 to infinity, and again, parenthesis around my infinity, and I'll do a bracket around my 2 since it's a closed circle. Now I'm going to do some erasing again. The next question says, what is the output if the input is 1? What is the output if the input is 1? So what I want to know is I want to know what my y value is when x is 1. So I go to my graph and I go to x equals 1. This is x equals 1. And I go up 1, 2, 3. It's 3. 3 is your final answer. Number 2, what is the range if the domain is 4? So what I want to know is, what is my y value when x is 4? So I go out to x equals 4, 1, 2, 3, 4, and I go up. 1, 2, 3, 4, 5, 6. So my my range is 6. What is the input if the output's 1? So in this question, I want to find out my input, which is x, when y is 1. So I'm going to go backwards. I go to y equals 1, right here, and I have to ask myself what my input is. Well, if I look, my input's 0, because I'm plugging in 0 to get 1. Now, what is the domain if the range is 2.5? So again, domain is x, range is y. So I'm going to go to 2.5. So here's 2, here's 2.5. I go over, and it's 0.5. And that's your final answer. Let's do this image. Is it a function? Yes, it's a function. It passes the vertical line test. I'll draw on some vertical lines. Passes, 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 passes. It passes the vertical line test, so it is a function. For my next question, I want to find the domain. My domain is x values. So if I look, I'm using the number 1, the number 2, the number 3, the number 4, the number 5, and if I look, my graph goes to edge, so it goes on forever and ever and ever. Whenever I have a graph that goes on forever and ever and ever, I can say that my domain is all real numbers. But you can also use some fancy notation and just do this symbol right here. That just means all real numbers. Your range now. I now want to find the range. I'll do my range in blue. The range are your y values, so I want to see how high to how low. Well, my highest is 3, and I'm going all the way down into negative infinity. So I can say about my ranges, if my highest is 3 and it's including a 3, I can say my range is y is less than or equal to 3. I can also say, if I want to write this in interval notation, that my range is negative infinity to 3. The reason why I put my negative infinity first is because that's smaller than a 3. I put a bracket around my 3 and a parenthesis around negative infinity. Try to do the next set of questions by yourself. So, for each of the questions, you should have gotten the following answers. What is the output if the input is 1? So it's basically saying when x is 1, what do I get? Well, at x equals 1, you get 2 as your final answer. What is the range if the domain is 3? Well, if you look at x equals 3, you see that I can plug in and I get negative 6. The next one should be a bit of a challenge for a majority of you. This is one that we haven't really done before. What is the input if the output is negative 1? So I want to find out what my x value is, but I only have my y value. Well, if I look, my y value is negative 1. So I have a negative 1, and I hit it at negative 2, and I hit it at 2. So I can say that my inputs are negative 2 and 2, which is exactly what I did. And then last but not least, what is the domain if the range is 3? Well, I go to my range is 3, so my y equals 3, and I hit it with 0. And that's it. Let's look at these examples. Is it a function? Well, if I look at this, this passes the vertical line test. I'm going to need to draw in my vertical lines. It is a function. It passes the VLT. My domain, I start to the left, so I look at my x value. So I start at 0, and I go all the way to 15. So I can say this. 0 less than or equal to x less than or equal to 15, or I can write it with brackets, just like this. My range, well, my lowest value is 0. I'm going to do this in red so you can see it. My lowest value is 0, so these are my y values, and my highest is 21. So I can say that I go from 0 to 21. So 0 less than or equal to y less than or equal to 21. If you want, you can also write this in interval notation by doing 0 to 21. Now, try to do these next questions by yourself. Those are your answers. What is the input if the output's 12? Well, I get two answers for that one. I can plug in a 5, or I can plug in an 11. For the next one, what is the domain if the range is 6? It's 13. What is the output if the input's 5? It's 12. And then last but not least, what is the range if the domain is 11? 12. Let's go on to the next one. Is it a function? Yes, it's a function. It passed the vertical line test. I now need to find my domain and my range. My domain I'll do in blue. My range I'll do in y. Domain are my x values, so it wants to see how far to the left I go and how far to the right I go. Well, if I look at how far to the left, I start at 0. Ooh, that's red. Because look, I hit a 5. And then how far to the right is 60. Because I get a y value of a little over, around 25, yeah. So my domain is 0 is less than or equal to x, which is less than or equal to 60. Or I can write it in interval notation as 0 to 60. My range is how low, so I'm going to erase my blue and now do some red. My range are my y values, so these are my y values. Right here. Ooh. So you would think that my range is 0 to something, but it's not because I don't have a y coordinate at 0. So my lowest is 5, and my highest is 25. So I can say my range is 0 is less than or equal to y is less than or equal to 25. And if I wanted to, I can write that in interval notation as well and do 0 to 25 and put brackets around them. Let's go on to this next example. What is the output if the input's 30? Let's do some of these by ourselves and then compare some answers. When I ask myself what the output is when the input is 30, I want to go to x equals 30, so I'm going to erase my visual and do some picture drawing. Looks much nicer now. The first question is, what is the output if the input's 30? So I go to x equals 30, right here, and I go up. I have to ask myself what y coordinate it is, and boom, it's 10. That's your final answer. Try to do the next one by yourself. What is the range if the domain is 10? If you did that by yourself, you should get this. Let me just do some erasing. My domain is 10, so I start at 10. I go up and I go over, and boom, I hit a 5. That is your range. Did the person stop where the graph is flat? Well, let's look at this. Doesn't necessarily mean that they stopped. What that means is, if we look at our y-axis, that's telling you your elevation, or you're above sea level in feet. They didn't necessarily stop, it just meant that their elevation was constant, so they're at the same elevation for the whole time. So they were at the same 10 feet above sea level. No, they were just at the same elevation. So we wouldn't say that they stopped, we would just say, no, they were at the same elevation. Now let's describe what's happening at each piece of the graph. Well, instead of writing this all out, it's going to take me forever to write this out on my iPad. We're going to just verbally say it. From 0 to 10 minutes, the person is walking at an elevation of 5 feet above the ground. From 10 to 20 minutes, the elevation is increasing, so he's walking uphill. From 20 to 30 minutes, he's at a flat rate, so he's basically at the same elevation he was just at. From 30 to 40 minutes, he goes downhill. And then from 40 to 50 minutes, it's pretty rapid, but he goes extremely higher in elevation, and then he stays at the same elevation throughout. Ladies, if you have any questions, please email myself, Ms. Townsend or Ms. Jimenez. Have a great, great day.